So they want us to graph the equation x equals y squared. Find any intercepts and check for symmetry first. Okay, so we'll find the intercepts. Intercepts, very boring. You should already be able to see, I think, that for our x-intercepts, when we make y equal to 0, that means we have x equals 0 squared. And so we just get x equals 0. And that's both of our intercepts, because you see the x is equal to 0 as well. So that's our x-intercept and our y-intercept. So let's start with the sketch of the graph. And then we have our intercept, 0, 0. And then test for symmetry. How do you check for symmetry before you graph it? Because I know how we do that with a function because it involves the f of x, but we can't really use the f of x here because it's not a function. But I suppose we could still think about it. So let's kind of think about what would happen when we plot points. Because when we plot points, I don't know why I made that one so long. When we plot points, we got our x value and our y value. So, and here, see, it's kind of weird. It's going to actually be easier to, like, think about this. If we plug in -2 or +2 for y, we're going to get out +4. And see, that's why this isn't a function. Because when we talk about functions, x is our input. I don't know why I put a dot there. But here we're saying when x is 4, there's two, when we input 4, we have two different outputs for y. And so that means it's not a function, which is like, we can still talk about it, but normally when we talk about things, we're talking about functions. So here, when we plug in y, when y equals -1 or when y equals +1, we get back out +1. So when x, but then reality, when we input x, when we input 1, we're getting back out these two different numbers, 1 and -1. And that's how the symmetry is coming from. That whether we plug in a positive y or a negative y, we're getting the same thing for x. Just like when it has y-axis symmetry, the idea is when you plug in a negative for x, you get the same thing as if you would plug in a positive for x. This is the same idea, just backwards. A positive y and a negative y don't make a difference. Okay. It's kind of cool. It's nice to think about those. Try to get really deep into it and like really see what's going on. And that's what's going on. It's just the same idea, but the x and y are switched because you're talking about x-axis symmetry versus y-axis symmetry. But now we can see our graph. I mean, it's a parabola. We see it right there. Cute little parabola. We can make it perfect if we want to. There we go. And that's what that looks like. And that makes sense because we should already know that y equals x squared is a parabola. And so if it's x equals y squared, the x and the y are just switched. So it's on a different axis. And that's great. And then b. How is b different? Well, b is like, yeah, notice how b, they're only asking for when y is greater than or equal to 0. So we can really just look at our graph. We don't need to do that. If they're talking about when y is greater than or equal to 0, well, if you need to remember that's the y-axis. So we just care about this part when it's greater than or equal to 0. So it's just the top part of that parabola. And how that really comes in to be interesting is that if we try to like make this a function, if we try to solve for y, well, we'd have to square root both sides. And remember, what do you always have to do when you square root both sides? You have to plus or minus. So you'll have plus or minus the square root of x equals y. But then notice how here they specified they only wanted when y is greater than 0. They only wanted the positives. So that's why we can reject this negative and only do the positive version. And that shows us that we should know that's the graph of y equals the square root of x. So we should remember that. That's what that graph looks like. That's another function. And we remember what it looks like because it's just a sideways parabola, but just the top half on it.